Okay, so this is the first problem. So we need to find the relative minimum of f of x given that it's ln of x squared plus e cubed. So relative minimum probably means we need to find f prime. So this is f prime of x. To get f prime of x, we need to do chain rule. So we do the derivative of the inside function. The derivative of the inside function is just 2x because the derivative of x squared is 2x. But the derivative of e cubed is actually 0 because e is a constant. So a constant to the power of a constant would be another constant. So, and the derivative of a constant is just 0. So this would just be 2x plus 0 or 2x. Then you multiply it times 1 over x squared plus e cubed because the derivative of ln x is 1 over x. So this is our, so 2x over x squared plus e cubed is our derivative function. So we need to find the critical values and test it on a y-sign chart. So critical values, so immediately we see that x equals 0 is a critical value because it makes f prime equal to 0 since 2 times 0 is 0. So 0 on the numerator is 0. And then if we try to make f prime undefined, that means just making x squared plus e cubed equal to 0. Then we would get x squared equals negative e cubed, and we can't square root a negative. That'll lead to complex solutions. So that's not a valid solution. So our only critical value is x equals 0. Put this on a y-sign test. We can test any number to the left of 0. Let's just test negative 1. We would get 2 times negative 1 over negative 1 squared plus e cubed is negative 2 over 1 plus e cubed. And this is a negative over positive, so this side would be a negative on the y-sign chart. Now we test something on the right of 0, so let's just test 1. We would have 2 times 1 over 1 squared plus e cubed, and this would be 2 over 1 plus e cubed. So this would be positive. So we found that x equals 0 is the relative minimum, but we actually need to plug it back into the original equation to find the relative minimum. So if we plug it back into the original equation, we have f of 0 is equal to ln of 0 squared plus e cubed, which is equal to ln of e cubed. Now, since ln, its base is e, the ln of e cubed is just 3 ln e. We can take the exponent out, and this is just 3 times 1, which is 3. So the actual relative minimum is 0, 3. So we need to find the place where the answer is 3. So let's find it. Not here, not here. Here. Okay, so the graph of f prime is shown. So we need to find the x-coordinates of all points of inflection on the graph of f. So this is the graph of f prime. So points of inflection is where f double prime is equal to 0 or undefined. So we need to see which points on this graph is f prime is equal to 0 or undefined. So we see that here at this point, x equals negative 2, that if you take the derivative of this, it's actually going to be undefined because I'm just like sketching here, but it's going to be something like this because this is basically like an absolute value function, and the derivative at x equals negative 2 is undefined. The slopes are changing. So x equals negative 2 is a possibility, is a point of inflection. Another point of inflection is at 1.5. So I'm roughly estimating here, but the tangent line at 1.5 is 0 because it's a relative maximum on f prime. So that means that f double prime would equal to 0 at like 1.5. And then we have another one at 2.5 here, where we're given the x coordinate. So 2.5, again, like -2, the slopes are changing, so it's going to be something like this and then here. So it makes f double prime undefined. So x equals 2.5 is another valid solution. So these are the x coordinates of the point of inflection. Let's find which question has these answers. So here. Okay, so let f be a function defined for all real numbers x, such as f prime x greater than 0, f double prime greater than 0. Which of the following remaining values could be the value of b? So we're given that this is a +3 increase and this is a +3 increase. So the slope between these points is positive. So f double prime is positive here, right? Because the slope is positive. Now, we're also given that f double prime is also positive. This means that the graph of f is increasing at an increasing rate. Basically meaning it's going to be, it's a rough sketch, but it's going to be something like this, where the slope is constantly increasing the higher x value you go. So if we skip another +3 and then we look at b, so we have a +3 here, so it would be the point would kind of be 3, 5, but since it's increasing at the slope is increasing at an increasing rate, this point is going to, so this line between these two first points is going to be flatter than this line right here. So the b is actually probably greater than 5 because we're increasing quicker, so it would probably be a bit more than 5. And that would lead us to assume that b is something like 6 because, I mean, it would be convenient, and that's also like the answer. So let's see where the answer is 6. So the answer is 6 here. So basically, we need to find where f double prime of x is less than f prime of x is less than f of x, given that this is f of x. So let's test like a couple points. So if we test this point at x equals -4, right? F of x is positive, right? This is positive, so f of -4 is positive. Let's write that. F of -4 is positive. Now f prime of -4, well, the slope is probably like a bit like this. This is probably the tangent line. So it's safe to assume that the slope at -4 is 0. But so f double prime of -4, so we see here that f prime is increasing 0, then it's decreasing and decreasing. So f double prime x would also, so never mind, let's forget that. But f double prime x being negative, since we need f double prime of x to be negative, since we need it to be less than f prime of -4, which is 0. So this needs to be negative. And the graph of f of x is only concave down. Remember, if f prime is negative, then fx is concave down. So fx down. So the only part of f of x that's concave down is probably like over here. So -4, f double prime of -4 is going to be negative, since this part is concave down on f of x, and yeah, so that means it's going to be a negative value. So we have these three. So if you have a negative, that's f double prime. which is less than, if it's 0, then it's f prime, and then if f is positive, so it's going to be like this. We've satisfied this inequality, so x equals -4 is our point. So let's find where -4 is a solution, and it's right here. So these graph f double prime, the second derivative, at which of function f is shown, which x value on the closed interval 0, 8 does the graph of f have the steepest slope? So the graph of f has the steepest positive slope. So if we're thinking about this, right? So the steepest positive slope, let's look at x equals 5, right? So the steepest positive slope would be somewhere where the concavity is changing. Because if you think about it like this, right? If this is the original graph, right? The steepest slope, let's draw a different one. Steepest slope would be right here, right? Matter of fact, this is also a point of concavity. This is because this slope is increasing and increasing, right? And then it gets to this slope, and then it starts decreasing again. So the point of the POI is where it's going to have the steepest positive slope. So given that this is the graph of f double prime, we would on its closed interval, so we would assume that x equals 5 is the answer, because a point of inflection happens when f double prime is equal to 0. So the steepest slope happens probably at the point of inflection, which is at 5. Additionally, since it's the steepest positive slope, why aren't we considering x equals 8? Because steepest positive slope, if you look at this graph, it can only go from concave down to concave up, right? You can't have up to down, because then that would be the steepest negative slope. So down to up. So you would have x equals 5. So yeah. So let's see where which question f equal is the answer 5. Here. Okay. So we are given a table f prime, f, and f double prime. Which of the values does f have a relative maximum? So relative maximum, two things have to happen. So f prime has to be 0. A relative maximum is a critical value. So f prime has to be equal to 0. And then a relative maximum also happens when f double prime is negative. Mr. Froome or whatever teacher you have or had taught this, but for a relative maximum to happen, you have to have the graph of f be looking something like this. This is the point, this is the maximum. F prime would be 0. F prime would be 0. So, and the concavity is down, so f double prime is negative. So we just need to check where f prime is 0 and f double prime is negative, and we're given that it's, if you look at the table, it's here. So at x equals -2 is where f has a relative minimum. Okay, let's find where the answer is -2, here. Okay, so this is the graph of f prime of x. So here, f prime. So the function is increasing on the intervals and decreasing everywhere else. Find d minus a. Basically, we need to like plug in points for a, b, c, and d. So if this is the graph of f prime, f is going to be increasing wherever f prime is positive. So we just need to find where f prime is positive, since that's where it's going to have a positive slope and f is going to be increasing. So we see here on the interval 1, 2 that it's f prime is positive, and here on the interval 4, 5 is also where f prime is positive. So if we have here A, B, C, and D, you would input 1, 2, 4, and 5. Sorry. But D minus A would just be here, 5 minus 1 equals 4. So let's find which question has 4 as the answer. Here, okay. So f is the function with derivative given by this long thing, g of x times sine of pi by 2x. The graph of y equals g of x is shown. Find all values on the open interval -2, 2 at which the graph of f has a relative minimum. So this is f prime, and the graph of g of x is shown here. So we need to find where f has a relative minimum. So where f has a relative minimum means that f prime has to equal to 0. So first, let's find the critical values. F prime is equal to 0, okay? So if we have this kind of equation here, sine pi by 2x, right? You can have two possibilities. Either g of x is equal to 0, or sine pi by 2x is equal to 0. So g of x equals 0, we see that it's happening here. So x equals -1 is a possibility, okay? So, g of x sine pi by 2x. So we need to find where sine of pi by 2x is equal to 0. So that's where this interval comes really handy. So if we remember, pi is somewhere around 3.14. That means pi by 2 is somewhere around, like, let's say 1.62 or something, right? So we can kind of like assume that this interval is going to be talking about like negative pi by 2, x pi by 2, okay? And you don't really need to assume, but in reality, if you like test it and graph it, there's not going to be any points like in between -2 and negative pi by 2, for example, that is equal to 0. So here's our like simplified interval. So sine of pi by 2x is equal to 0. So if we like draw like a unit circle, that's what I like to do. So where is it sine equal to 0? Sine's equal to 0 here and here. So at 0 and pi. So so that means that pi by 2x has to equal to 0. So that means that x equals 0 is another possible critical value. And if we check if pi by 2, so pi actually can't happen because pi would be -3.14 or 3.14, which is not inside our interval. So pi actually can't happen. That means that for the case that pi by 2x is equal to 0, x equals 0 is the only critical value that we can find. So this is a long question because now we have to do a y sign test. So here, -1 and 0, since these are our critical values. If we check to the left of this, so -2, g of negative, so g of -2 times sine pi by 2 times -2. G of -2 we're given is 1 times sine of pi by, if pi by 2 is multiplied times -2, these cancel out, so negative pi. So what's the sign of negative pi? That's just 0. So this is 0. So actually, let's check another case. If we check something like g of -3 times sine of pi by 2 times -3. So g of -3 is 2 times sine of -3 pi by 2 is positive, so 1. So, wait. Let's check to the right first. So, here, if this is equal to 1, right? If the point we're testing is equal to 1, let's delete this. Actually, I don't think we need this either. Okay, so if the point we're testing is 1, that means that we need to check what this is. So sine of pi by 2, right? G of 1 is -2 times sine of pi by 2 is what? 1. So this is -2. So this would be negative. If we check in between these two values, negative, let's say 0.5 or something, right? It would be g of negative 0.5 times sine of pi by 2 times negative 1/2, okay? So g of negative 0.5 is somewhere like here, so it's negative 0.5 times sine of negative pi by 4. If you draw this, negative pi by 4 would be here, it's negative. So it's a negative times a negative, which is positive. So just based on intuition, you don't actually have to check where f has a relative minimum, because you don't have to check any numbers below -1, because we're given that these two are our only possible solutions, yeah? And if the graph of f prime is going from positive to negative at x equals 0, that means that this is a maximum, right? Positive to negative, so maximum. So we need to find, how do you get this ruler off? How do you get this ruler off? Okay, let's just move it. So that means that it cannot be at x equals 0. So based only on intuition, x equals -1 is our answer. Sorry, I don't know if I was like wrong or something, if it was less than -1. So let's check where the answer is -1. So answer at -1 is at here. Okay, so another big looking problem. So find the y values of all critical points here. So obviously we need to find dy over dx. Dy over dx. So let's take the derivative of both sides. So this is 8x. So this is going to be chain rule. So minus 2y times dy over dx minus 8. This will become 0. This will become 0 is equal to 0. So 8x, so 8x minus 8 is 8x minus 1 is equal to 2y times dy dx, right? And then we would divide both sides by 2y. So we have, let's erase this. Dy over dx is equal to 8 divided by 2 is 4. So 4x minus 4 over y. So this is our derivative function. So we need to find the critical points. So we need to check. So x equals 1 is a critical point, right? And then so you would plug that into the original equation. So 4 times 1 squared is 4. So minus y squared is y squared minus 8 plus 4 is equal to 16. So this. So minus y squared is equal to 16. So you divide both sides by -1. Y squared equals negative 16. Again, y cannot be an answer. You can't square root a negative number. So x equals 1 doesn't work. Now we try y equals 0. Not all the times we have to test x values. So we test a y value. So y equals 0. So if we input that into our original equation, 4x squared minus 8x, and then the 16 can come over here, so minus 12 is equal to 0. Yeah, so then we can factor 4x squared minus 2x minus 3 is equal to 0. My goodness. And this would be like 4 times x minus 3 x plus 1 equals 0. Sorry if I'm running out of space, but well, actually the x values don't really matter because we're asked to find the y values. So this is actually the only y value that will give us a critical point. So 0 is the answer for this question because this is like the only y value that will give us a critical point. So now we check where it's 0, it's here. Okay, so find all x coordinates where f has a relative minimum. This is the graph of f prime of x. So relative minimum means that the graph of f prime is going from min, so negative, to positive. So where in this graph is the y value going from negative to positive? Well, we see here at x equals 1 that it's going from negative to positive. It's negative here, and then it's positive here. And also here at x equals 4, it's going from negative here to positive here. So this question is pretty straightforward, but our answers are x equals 1 and 4. The answer is here. Okay. Almost done. I think this is number 11. Yeah, 11. So we are given the graph of f prime, and we're given intervals like the other problem that we did. So we need to find a, b, and c and add them up. So, and a, b, and c are like the endpoints where f is concave down. So a neat trick here is that if this is a graph of f prime, where f, so it's concave down when f double prime is negative, right? So we need to find where f double prime is negative. And f double prime is negative because f double prime is negative where f prime is decreasing. So decreasing. So this is because f double prime is basically like the graph of the slopes of f prime. Here you can see if f prime is decreasing, that means that the slope, that means that f double prime here would be negative, right? And here, if it's increasing, that means the slope is positive. So, but we're trying to look for concave down. Concave down is where f double prime is negative. So we need to find where f prime is actually decreasing. So, for example, this example here is a really good place because f double prime is f prime is decreasing and f double prime is negative, meaning that f is concave down here on the interval -5, -2. Then also where it's decreasing is, looks like between here and here. I'm assuming that this point would be like 1.5 and then 2.5. So we have our A, B, and C. If we add them all up, this would be 2. So our answer is 2. And last question. I hope we got this all right. Where's 2? Here. Okay. So, pretty straightforward. The graph of G has a point of inflection. So we need to find all the x values. So find G prime of x first. So just a bunch of power rules. So we would have 6x squared minus 30x plus 18. Then another derivative, we need to find G double prime because we need to find point of inflections. So this is 12x minus 30. So The only place where g double prime would equal to 0 or undefined. So let's say it's equal to 0 equals to 12x minus 30. Let's down minus 30. So 12x equals 30. X equals 30 over 12, and this can be simplified to 5 over 2. So or also like 2.5, I'm pretty sure. So this is the x value where g has a point of inflection. G double prime is equal to 0 at 2.5. So if we look at the original question, answer is 2.5. All right, thank you.